Hello, my dear students. Today we'll resume what we started about energy. Energy can exist in many forms: heat energy, light energy, nuclear energy, chemical energy, like from food or fuel, stored energy, which we call it potential energy, such as the energy stored in compressed spring, and so on. Energy can be transferred from one form to another and can be used to create motion. Energy is a scalar quantity. It can be positive, it can be negative, but it is scalar, like no direction, like we said before in work. And both of them are measured in joules, by the way. In mechanics, we are only interested in mechanical energy. And we have two types of mechanical energy: kinetic and gravitational potential energy. Kinetic energy is the energy that a body possesses because of its motion. A body of mass m kilogram moving with a speed v meters per second has a kinetic energy given by half mv squared. You just multiply half by mass by the square of velocity. Kinetic energy could be measured in kinetic energy. It is the red one. It is half mv squared. So it is measured in kilograms. This is mass. Velocity, which is meter per second, and then you square it. And when you distribute the power, so it will be kilograms meter per second squared into another meter. So is this the units of measuring, which is Newton meter? Yes, it's the same. So why don't we name it joule? Yeah, it's the same. So it's the same units of measuring work. Here's a worked example. Find the kinetic energy of a body of mass 3 kilograms moving at 5 meters per second. You will just multiply. We need to find kinetic energy, mass, velocity. So KE is half mv squared. Say half mv squared. Half mv squared. Just calculate it. It is half multiplied by mass multiplied by 5 squared. The answer will be 37.5 joules. Second example. A body of mass 50 grams, not kilograms, hits the ground with a speed 10 meters per second and rebounds with a speed 6 meters per second. Find the loss in kinetic energy that occurs in the bounce. The word loss, it means you should find the kinetic energy, which is final kinetic energy, minus initial kinetic energy. Okay? 50 grams, this is the mass, should be converted. This is the speed. No, this is the initial speed, and this is the final speed. And we need the loss in kinetic energy, which is kinetic energy final minus initial. Does this make sense? Yes, it does. So, first of all, convert. Mass equals 50 grams divided by 1000. To change it in kilograms, it will be 0.05 kilograms. And now we have to find the change in kinetic energy. Equals the final kinetic energy, which is half mv squared, minus the initial, which is half mu squared, and we just calculate half multiplied by, we can take half m as a common factor, but we cannot take the squaring as a common factor. You have to subtract the square of the velocities. Okay, so half into 0.05, I can open brackets and find v squared minus u squared, which is 6 squared minus 10 squared. Of course, we expect that the answer is negative because simply it is loss. But when we say the word loss, we remove the minus. Okay, so if you want to calculate each kinetic energy individually, kinetic energy before, and you find it in joules, kinetic energy after, and then you subtract them, no problem. So the loss will be, so it is negative 1.6 joule. So to say the word loss, don't mention the sign. Loss in kinetic energy is 1.6 joule. By the way, I'm reminding you, if you need to find initial or kinetic energy before, you calculate it. This is before rebounding. It is half multiplied by mass multiplied by 10 squared. And kinetic energy after rebounding, it is half multiplied by mass multiplied by 6 squared. You find both of them and then subtract. Next. Now we'll speak about gravitational potential energy. This is another type of mechanical energy, which is the potential energy. It is this energy, it is the energy that body possesses because of what? Only its position. Its position where? Above a certain base. You can choose the base and measure all heights from this base in this question. Gravitational potential energy that could be released if the body falls under gravity. So it is stored and waiting to release. Stored because of its height above a certain base. If mass m kilograms has a height measured in meter, its potential energy will be mgh, measured in joules. Potential energy mgh, potential energy mgh, potential energy mgh. The amount of potential energy that a body possesses depends on its height. The height is measured from a base level. At this base, potential energy is 0. We can choose any level, as I said before, to measure from. Now, here is a question about find the increase in potential energy in raising a sack of mass 1 kilograms through a height of 3 meters. Increase in potential energy. The mass, this is m, this is the height, and you'll simply answer like increase in potential energy equals mgh. Mass is 1 kilograms. What is g? It is gravitational potential energy. So g is the gravitational acceleration, which is 10. And the height above the ground is 3 meters, so it will be 30 joules. When a body of mass m is raised through a height h, the work done against gravity is mgh joules. Work done against gravity. And the increase in gravitational potential energy is mgh. So potential energy increases when the work done against is done against gravity. So objects at a higher level have more potential energy than those are at a lower level. When the same body descends through a vertical distance, h meters, the work done by gravity is mgh, and the decrease in gravitational potential energy is mgh, joules. So potential energy decreases because the height decreases, right? And potential energy is directly proportional to the height. When height decreases, potential energy decreases too. Okay? So, potential energy decreases when work is done by gravity. What matters the vertical height difference between the top and the bottom, even if it is sliding on a slope? We are considering the vertical height. Again, what matters is the vertical height difference between the top and the bottom, even if the body is sliding down a slope. The last thing to mention is the modeling assumptions. It's always, we are assuming objects as particles, even if a whole car with wheels, we consider the kinetic energy of an object, we assume that the entire object moving at the same speed. The whole object is moving at the same speed. This is often not the case. For example, the wheels of the car, they are rotating. So the point at the top of the wheel is rotating like that. It is faster than the car itself. And the point at the lowest point of the wheel is moving more slowly. But we will consider this difference as negligible and consider the whole car as a particle. This is the modeling. Experimenting with a ball rolling down a slope will show that the speed at the bottom of the slope is not as high as expected. All these are modeling, and we will handle it very soon. Thank you. See you in the next video with work, energy, and power. Bye-bye.